about constant additive rate of change about that linear function? Bakari?
Slope.
What's that constant additive rate of change known as?
Slope.
Slope. Okay. Anybody able to add anything more onto that information? Okay. Y equals mx plus b. B is the y-intercept. Okay, so m is equal to rise divided by run. Is there anything else we could add on to about that m or that rise divided by run? The delta signs.
Oh, the change in y.
So the change in y divided by the change in x, right? So remember, rise divided by run is really good for a graph, right? But change in y and change in x is really good for a table. One thing, I didn't show this before, but I do want to just note this really quickly. You all had to find slope between 2 points like this, haven't you?
Yes.
Yeah? And didn't you always have to do that really fun formula of y2 minus y1 divided by x2 minus x1?
Yeah.
Did anyone ever make mistakes with that?
Sometimes.
Sometimes. You ever mix it up maybe with, I don't know, the distance formula or the midpoint formula, and we forget where the y goes and where the x goes, etc.? I used to, right? But I want you to think about this. What is this again? It's just the change in y. How much is that y changing? 23 to 18. It's how much?
5.
Okay. Plus or minus? So 23 plus 5? Oh, no. Is 18? No. Minus 5, right? Okay. What's happening to go from negative 8 to negative 6?
2.
Okay, is that adding or subtracting?
Subtract.
So think about your number line, right? If I'm at negative 8 and I want to get to negative 6, right? Because we got to get to 0. Isn't that going to the right? So I'm adding 2. Once we learn to just play around with it and use calculators, subtract or add, things like that, the change in y divided by change in x becomes a much easier way to approach slope than having to do y2 minus y1 divided by x2 minus x1. It's super easy to flip the order, things like that. Okay, so that's I just want to quickly show that. So what is this known as again right here?
Slope. I mean the y-intercept.
So remember, this is the, what is this in?
That's a rise to the run.
Okay, but what is that rise divided by run? Rise divided by run is how we calculate it. M is what? Slope, right? M, we got to know, M on its own is slope. B is, so what is this entire equation? Slope-intercept form of a line, okay? We need to understand that idea. It's the slope-intercept form of a line. Constant additive rate of change known as slope. And a lot of this information can go on the graph as well, especially that equation. Notice we also have this sheet for graphically. What's the last detail that we need to add on for linear functions when it comes to that graphical side?
Exponential.
No, for linear.
Oh.
If we're talking about a graph and we're talking about a linear, what's a note we should make?
The input is 0 slash x is 0.
I'm going to come back to that in a second.
We need to see Caden Smith in the office, please. Caden Smith.
He is on his way.
Thank you.
Hayden, why do you have your phone?
My bad.
He already know. He just
So, 2 phones for him in the future. Moving ahead, coming back to this, guys, what I'm talking about is graphically, what do we need to know about linear functions? Say it again. Guys, it's a line, right? If we're talking about a linear function graphically, what do we see? It's a line. Woo. Okay. That's a big recap of all things linear. Now what do we got to talk about that some of us are trying to jump to? Exponential, okay, so we should have talked about this a little bit. Maya, did y'all talk about exponential at all? Did y'all get there? No. But did you? Did you talk with her about it? Maya, let's get our headphones off. It makes it easier to talk. J Mike, we got to actually make sure we're trying to talk with each other. You are responsible for your learning, but you're also responsible for your group members' learning, okay? That's how groups work. You are responsible for helping each other grow and learn. That's your miniature family for the day, and then we're a larger mathematical family every single day, right? You are responsible for helping each other grow and learn. And when you do that, you're going to come out way further ahead in the long run. Let's see. Kennedy, what did y'all talk about with exponential? You didn't talk about anything with exponential? Ooh, it hurts my heart. Deanna, what did y'all talk about with exponential? Say it again. Okay, so I'm going to erase, I'll just write the notes here. Going back, so exponential, right? So remember, where do we see rates of change the best, by the way? In tables. That's why I'm putting the rate of change under the table section. So when we say exponential, oh, sorry, I meant to mention this one note because someone mentioned this earlier. By the way, y-intercept. How do we know when we have the y-intercept? Say again. Yeah. Say it louder. Where what meets? Which line meets what? So why is it called a y-intercept?
Wait, what was your question? Say it again.
Because it's the, well, it's not, it doesn't have to be a line. Any relation intersects what?
What was your question?
What do we know about every y-intercept that's ever existed?
Oh, you talking about the S0?
Okay, so the relation intersects, I heard Taj say something. Intersects the y-axis. And so, what did you say again, Dewan?
The X is 0.
So, the x or the, what's the other word for that x?
On the input.
The input is 0. Okay? We gotta know those background pieces of information. Now, moving into exponential, what did Deanna say earlier? The exponential has
A multiplicative.
constant multiplicative. And it's important that we put that word constant, because multiplicative just means we're what? Multiplying. The fact that it's constant multiplicative means that we are multiplying, not just like when we say constantly, what do you mean by that? Repeatedly multiplying by the same value, right? I want to emphasize that constant. It's the same value over and over and over again. It doesn't change. So that's the beautiful part. But we knew the name of that constant additive rate of change. What was the constant multiplicative rate of change known as?
You said what?
What's that constant multiplicative rate of change known as? With a what? No, not an E.
What letter is it?
It starts with an F.
Oh, constant factor. Yeah, constant factor.
What do you do with factors? You
Multiply.
multiply them. What are the factors of 6?
Well, wait.
We're like, what are some factors of 6?
12,
2 and
4,
3.
Oh,
Hey guys, what's 2 times 3? 6. What's 1 times 6?
6.
So those are factors of 6. They're things that are being multiplied. So, Vakar, you were jumping to multiples. 6, 12,
Yes.
18. Those are multiples, not factors. So constant factor.
Miss Kim.
Yeah,
So I'll just be written on graphically because I have all this stuff on
That's fine.
calculator there.
that's fine.
Okay.
Okay, what else do we need to say about that exponential? Constant multiplicative rate of change known as a constant factor. What else do we need to say? We got the rate of change. Say again. Yeah, well, what should we know about, yeah, what did we talk about in our groups, but also exponential, what do we know? Repeated multiplication turns into an exponent. So let's talk about that. As an equation, how do we see that? Say again. Anyone write down that equation yesterday?
I know it.
We gotta know that equation.
What about
A times B to the X. A times B to the X.
You remember how Amber just said repeated multiplication turns into a what?
Exponent.
An exponent. Notice the exponent is a what?
X.
What's another word for that?
Variable.
A variable, right? Notice, because we can keep changing how many times we multiply by b, right? By the way, what's that b called again?
Base.
It is a base. That is part of the reason why I use a b. Now, and so this is why I'm covering this, because remember, a b was the y-intercept here, but that's not a y-intercept.
Can I get the letter?
Say again. Say again. You can't see, so you need you want to move up here so you can take notes?
What's the letter of the word again?
I don't know. It might be on the board though. Remember, you just said that b is what we are.
Oh, the factor?
Oh, say it again.
Factor.
What b is repeatedly what?
Multiply.
Multiplying. So what's it called? A constant factor.
I
I didn't hear you. My bad. I only have 2 ears. I make mistakes. Constant factor, right? Literally, Amber, you talked about the fact that repeated multiplication is shown as a what? And as an exponent, right? Oh, please notice and remember this idea. Repeated addition is shown as what? Multiplication, which is, where do we see the multiplication in this equation? M and x. They're being multiplied because you're constantly, repeatedly adding that slope. Whereas here, you're constantly and repeatedly multiplying by b, the constant factor. So what is the a in this equation?
It changes.
Remember, the variable is x. So remember, b is my constant factor, just like m was my slope. So what's that a? Say again. Is the what? Hey guys, I want you to think about it. Isn't that where we're starting this equation?
Yes.
And what's that starting value called?
Y.
Y-intercept. Yeah. The a, notice how many times do I have that a? Once. So that is my starting value or y-intercept. Right? So these things are not random, they have meaning, and if you understand that meaning, one, there's beauty in that, and two, it's way easier to understand. Promise.
Understood.
Appreciate you, DeLon. I mean, I put this under tabular because it's focusing on rate of change, but you put it where you need to.
That was a big tall guy.
What up, Tyler?
What you saying?
Hey,
What you saying?
We're not there yet. If you look around, DeLon. Hey, DeLon. DeLon, if you look around the room, that's where we're getting again on Monday.
Oh, that's
Okay. Huh? Well, I'm introducing it Friday in a way, but not with the finalizing idea. Huh?
You said Dr. Somebody.
Dr. Johnson's coming tomorrow from UWA. Alright, really quick, last question. We talked about that exponential graphic, or tabularly, we've talked about it algebraically.
Yes.
What should we say about an exponential graphically?
You said exponential. You got exponential curve.
It's got an exponential curve. Remember, that's part of the name. Please note an exponential curve can increase, or an exponential curve can what? Decrease, right? So, keep in mind the name of that exponential function is an exponential curve. Hell, you're not even in the frame if you just sat where it was.
You know why I'm moving like that.
Huh?
You know why I'm moving.
Oh, okay. So, did I pass out the practice with linear and exponential yesterday?
Yes, sir, you did.
I think
We talking about this right here.
this right here. I don't think I did.
I don't think you did, sir.
This?
Nope.
I have not passed this out yet, have I?
Sir.
Okay. Let's do this. Brady. Get everybody on this side of the room, be aware it's 2 sheets. Guys, there are 2 sheets that you need off of this. Mel, everybody on this side of the room. There are 2 sheets that are stacked on top of each other. Please go ahead. Pass those out for me. Now that we have ideas shared. I'm going to mix up the groups again. Yeah. I noticed a duo that I definitely did not have in the same group, which means cards got shared or something like that. Sorry, one person had to go and ruin it. You're going to move to these groups after I finish passing out the cards.
Come on, read it, man.
I know.
Mama, you're doing too much. Why we can't do that tomorrow?
I'm saying though.
You already gotta go to the bathroom.
What?
What is number 10? I'm trying to be sitting one. Bitch, can you give me another card?
Okay.
Give me another card now. What number you got? You got the same thing? You got the same thing? What you got?
I'm good. I'm not seeing nobody.
Thank you. Yeah. Oh, we got 81 did not go to the right person? No, that was somebody else.
What you got? Let me be filming tomorrow. Okay. Excuse me. Well, why was you trying to step over here where you see all this stuff? Don't lie like a smart person would do.
Okay.
Hey, Taylor, you got your stuff.
Okay. So, with today, right, we did a quick recap of everything linear versus exponential. But, is it fair to say, hey, excuse me, is it fair to say we need some practice with these ideas?
Yes.
We need to practice writing the equation. We need to practice, say again? Oh, that's J Mike. He'll be back in a second. Just grab a seat with the 9s for now. We'll get him to the right spot. He had to run.
Is my desk supposed to be in this place?
It's fine. Okay, so linear versus exponential. This is what we're practicing with. We need to practice writing equations from any representation. We need to practice. Oh, I did.
Wait.
Todd right here because it was a 9. I read it.
That's fine. It's fine. All right. So what I want to point out off of proficiency scales is this. If we look at the foundation for identifying functions, again, have we talked about determining if a relation is a function?
Yes.
So hopefully we can mark that off. There will be a part of today's task that will help you practice it. Have we talked about identifying the type of mathematical representation?
Yes.
Yes. We got to know the difference between mathematical representations and types of functions. That vocabulary matters. Have we looked at the terms relation, function, mathematical representation?
Yes.
By the way, if I were you, I would have had my proficiency scale out because one, it has really important vocabulary on it, but two, this is going to be a reflection piece for you of, hey, can I do this thing or do I need to study this? So can I do this thing or do I need to study this? Okay? So that's the foundation pieces. Also under identifying functions, is there anything we have not done under the target section, what we're trying to get to?
Quadratic. What is it? Quadratic. Oh yeah, quadratic.
So we haven't done quadratic yet? And we haven't done what?
Equivalent.
Okay, so I'll talk about equivalent as a part of today a little bit later, okay? So I'll talk about that a little bit later. But yeah, we haven't talked about quadratic functions. Dr. Johnson is going to introduce us to quadratic functions tomorrow. We're going to do way more than one day.
Oh, that dude that you said.
I was like, you know Dr. Johnson, you've met him.
I did.
Yes. Do you remember the carts? And we had the
that's
sensors. Yeah, that was a fun day, wasn't it? It was good learning. All right. So, Dr. Johnson from UWA is going to come in. He's going to do some activities with us to help us understand the importance and applicability of linear, exponential, and quadratic in the real world. Okay? But that's tomorrow. So, And then moving on to functions with constant rates of change. Have we talked about these terms? Linear function, slope, exponential, constant factor,
Yes.
slope-intercept form of a linear equation, x-intercepts, y-intercepts. Hopefully those are all ringing a bell. Today we're going to practice with this idea of determining the constant factor of an exponential, determining the slope of a linear. So if you can't mark those off yet, that's okay. I would hope we can do linear or the slope, but it's okay if you can't. Only mark stuff off that you are confident you can do. The real target today is this: creating equations for these functions, creating graphs when you're given an equation, and creating a table when you're given an equation. That's what we're really focused on today. All right? So those are the different things that we're looking at. I would keep my proficiency scale with us. Now, here's the first part of this practice activity. The very first part is simply this. I have given you 3 different functions. Okay? I have given you 3 different functions. And what I am asking you to do is, I want you to explain how I got this equation, because this equation is correct, based on this graph. I want you to explain how I got this equation based on this table. Actually, I'm thinking about it. I'm going to switch things up. We're going to do this second. Sorry. I just made a decision based on what happened in first block. 4. All right, so we're going to start with number 4. This is a better one. 1, you'll notice there are 11 different relations. I actually might have upped it a little bit, but it's at least 11. There are 3 things I need you to do. I need you to identify the type of what? Representation. Then identify the type of relation as a linear function, exponential function, or neither. If the function is linear exponential, write an equation, okay? So, what I want you to do is I want you to go to your vertical surfaces, label the problem. So we're starting with number 4, and do A, B, and C. Now, hear me clearly on this. I want everybody actively engaged. I need you talking about these ideas to make sure everyone understands. And on top of that, when you finish number 4, that writing device needs to rotate to the next person. So every 3 problems, everybody should be writing. Okay? I also would highly recommend 1 calculator per group. Not everyone has a calculator. 1 person has a calculator. And then, again, rotate it. What are your questions about these directions? When you finish number 4, move on to number 5. If you finish number 5, move on to number 6. But don't rush it. Make sure you're learning and understanding. Alright, let's get up. Let's get to work. You got a question? No, vertical surfaces, if you want to then copy it down onto your paper after we talk about these, that'd be a great idea. Yeah.
Mr. Ken.
Yeah.
Brother left. Kind of forgot.
Which one are we focusing on?
Right here. Okay? First things first. Has anybody figured out yet what you...
What I want?
I need you two to get away from each other because you like to distract each other. I'm so sorry. Did I hurt your ego?
Get his word out.
Like, I'm trying to make sure that you can focus, guys. Okay. So, has anybody figured out yet what you need to figure or what you need to do or identify before you start trying to write an equation?
Yes.
What is it?
I need to identify my B. Wait, what was we talking about? What was we talking about?
What's the first thing you need to do in order to start writing the equation?
Oh, look at the table.
Identify what?
Oh, my factor?
Okay, not just is it linear or non-linear, if it's linear or exponential. Guys, if you don't know what type of function it is, okay, if you...
But technically, you got to look at your table before you find out what that is. So you got to get.
That's a part of it, but I need one more clarity. Guys, here's the thing. If I know or can figure out that the function is exponential, what's the equation that I need to use?
Okay.
What's the equation?
A times B.
Be careful. F of x, right? It's a function equals.
MX.
A times B.
Remember, if it's
M times X.
Oh, A times B to the
M
X.
times X.
A times B to the X.
Guys, listen. One of the most common mistakes, and I happen to see it on someone's notes already, is they have plus here. We cannot have a plus because what are we repeatedly doing? Multiplying, okay? If you know it's exponential, that's the equation you want to use. If you figure out that it's linear, what's the equation you want to use?
Well, you said what happened? Say that again.
If it's linear, what equation do you want to use?
MX plus
MX plus B.
If you can identify the type of function, immediately write down the equation so that you can start to figure it out. I promise you, way too many students try to just figure out the equation without writing that down. But if you write this down, that's going to help you figure out the equation.
Yes.
And so when I'm looking around, right, I see this information, right? But as a quick reminder, what do we mean by A? The y-intercept.
Yep.
So when I look over at this table, is the y-intercept 3?
Yeah. Wait. No, it's not.
No.
Caden, you with me?
It's not.
Kari, you with me?
I just write notes.
I see you actively. I'm talking about the people that are looking away. I want to try to make sure we're here. Listen, guys, where do I see my y-intercept in that table?
Hey, 0.
At 0 with what? What is 0? The input is 0. Because I want to caution, right? If the output is 0, that's not a y-intercept. If the output is 0, it's an x-intercept, right? So we got to be careful about that. But if my input is 0, there's my y-intercept. Okay, so for this number 5, what is A?
2702.
So y-intercept. What is B again?
Now you guys for the actual answer.
Power.
What is B?
Hold up.
Square.
Factor.
But it's a constant what?
Factor.
Factor. Guys, I need us to pay attention to this. B is the constant factor. It's the base of that exponential. And so remember, I left off earlier with that table and I pointed out, hey, 4 times my factor is equal to what? 4 times the factor is equal to? 6.
Yes.
How are we supposed to figure out what my factor is from that equation?
Calculator.
But like, I gotta do something before I pick up that calculator. I gotta think first.
Plus 2. I mean, 4. That would be 6 though.
Be smart.
But what, hold on, look again at that.
I see a time.
What's happening between that 4 and that F?
That's a multiplication time.
Oh yeah.
They're being what?
I know it's multiplication.
Multiplied. So Caden, what do I need to do to solve that equation if 4 and F are being multiplied? Say again? Multiply? By what? So, that's going to tell me what F is? What's 3 times 4?
You gotta do 12.
Hold on, what's 3 times 4?
12.
12. 12F equals 18. Does that help me get F?
No, you gotta do what you call it.
You gotta divide 12 by 2 sides.
So at this point, I could divide by 12. Like I can do this, but come on, guys, let's go back up to here. What's happening between 12 and F? They're being
Multiply.
multiplied. Caden, what undoes multiplication?
Division.
Right? The inverse of multiplication is
Division.
division. Now remember, in this exponential is a big reason why I don't actually write as division. I write it as a reciprocal. But literally, what does this fraction bar mean?
Divided by.
So that is 1
Divided by 4.
divided by 4. So 4 divided by 4 is
1.
So how many F's do I now have?
1.
1 F, or just F. Whenever I do to one side of the equation, gotta do to the other. Guys, you gotta pay attention to what operation is there so you can undo it.
Excuse me.
And if you type that into the calculator, some people who have already done it, what is 6 times 1/4?
You said 6 times 1/4?
Yep,
What is it?
it's already written on that whiteboard behind me.
Whiteboard behind me. You don't have a whiteboard behind you, brother. Man.
My brother, right there. The whiteboard behind me.
Oh, you talking about 3 halves?
Oh, there we go. Woo!
My fault.
Come on now, brother man.
Yeah, we can wait.
Yeah, he needed to wait, Kevin.
That's so quick. Can I tell you something? I still don't understand.
Yeah, I'll help you in a second.
I'm so confused about it. So confused.
I'll teach you, brother, man. It's all
You
good.
said it's show.
Guys,
Let's just keep going. Okay.
I'll work with you in a second, but hopefully, does this make sense how I'm getting my constant factor for some of us that were missing it earlier in writing our equation? So, notice this B becomes 3 halves raised to the x. Now, for those of us struggling with number 6, I want us to look at this really quickly. right here. Number 6, so it's either going, if we're going to write the equation, it's either repeatedly multiplying or repeatedly adding, right? So when we look at number 6, what's happening to the y values every time? Subtracting by 6. And y'all understand, hopefully, that subtraction is a type of addition, right?
Yeah.
Lopez.
Okay, we're not comfy with that idea? Okay, let's talk about this. Hey guys, isn't adding a negative the same thing as subtracting?
Yes.
So subtraction is just a type of
Addition.
addition. That's why I was able to rewrite division using multiplication, because division is really just a type of multiplication, right? Like they're connected ideas. So this is what type of rate of change?
Additive.
Not just additive.
Linear additive.
No,
Wait,
not
what?
linear additive. Constant.
Oh, constant additive, my
It's
fault.
the same thing over and over and over again. And so again, we wrote it over there. As soon as I know it's constant additive, it's linear. So what equation am I using?
Y equals mx plus b.
And once I write that equation, that should start to trigger some things. It should help me remember, oh yeah, how do I calculate m? What is m? That's my... No. Slope. M is my slope.
Yes, sir.
And how do I calculate that slope?
Rise or run. Change the x by change y.
Wait, remember, it's rising. Which variable is rising?
Y.
Y. Which one is running? X, right?
Oh, so
it's
y.
the change in
Y.
y divided by the change in
X.
Hey guys, and if you want to, you can do this all of it, right? Literally, physically do this thing. It's going to help you remember the change in y divided by the change in x. Rise and run. That's it, okay. So what's my change in y?
You said what's your change in y? Negative 6. Well, minus
6. What's my change in x? Plus 3. So what's my slope?
2.
So notice, I've already got my m. Now, Jaquel, remind me, what does this B stand for again? Don't be disrespectful.
I don't think you see it.
Okay, let me ask you this. Do you remember the name of this equation?
I know. Why intercept?
Remember, it's the slope
Yeah, that was it.
intercept form, right? Y-intercept right there. Hey guys, do you see the y-intercept in this table? Do you have an idea how we might find this y-intercept?
Not at all.
Not at all, Maya?
Number 10, I don't know something like that. But it's like, maybe, like, you're a good teacher, but I just can't get it. Like, you better
Hold on,
Same here.
back up. You can't get it.
Ease up. Press the brakes a little bit.
Guys, pause. We have spent 30 minutes on 3 problems. You're telling me that we need to pump the brakes 3 problems in 30 minutes? Come on. I understand we gotta continue practicing, but I can't pump the brakes much more than that. Okay, pause for a second.
The big words you use, like, you understand.
I'm precise with my language. I use the language of
Like,
what math
I
is.
thought it was great.
Nope, this is math. We're learning math. Jamie, what were you gonna say about finding that y-intercept? Remember that y-intercept, the input has to have 0. We have an input of 0. No. Not yet.
No, we got input 0.
But that's my question. Okay,
You
look
gotta
guys,
keep going.
can I go backwards to get to a 0?
Yes,
Sorry, I gotta erase this a little bit. If I go backwards,
6.
what's 3 before 9? 6.
3.
And so I gotta go back how far? 6. So I'm gonna add 6.
Yep.
Okay, I'm gonna keep going backwards. What's 6 before, or what's 3 before 6?
3.
2.
I'm gonna go how far back
Never
this
mind.
way? How far back am I gonna go this way?
6 again.
6 again, so I get to
32. 0.
if I go back 3 again, I'm gonna go back 6 again. Hey, do I have my y-intercept now?
Yes, you do.
Okay, so, hold up, listen. Guys, I hear grumbling and I get it, because we're struggling with it, that's okay. What I want you to do right now, though, is I want you to grab a seat at your group. I want you to take some notes, and I'm going to come around and help answer questions for those of us who have those questions. But you can also talk to your small group. Improve your understanding, but I will remind you, what is the first thing you need to do if you're trying to write an equation?
Look at it. You got, find out if it's
You gotta figure